Hi guys, I'm Samriddhi Agarwal from GaugeHow. In this video, we will learn about fuels used in IC engines. The section of fuel to be used in an IC engine is as important as the engine design. The chemical energy of the fuel is converted into mechanical energy by oxidation of fuel inside the combustion chamber. The whole process of combustion results in the generation of large amount of heat energy. There are different types of fuel with different characteristics and properties about which we are going to discuss in this video. One major reason because of which we study about fuels is the concern of the environment and level of pollution caused by burning of engine fuel. An IC engine can work on solid, liquid, and gaseous fuels. Solid fuel. When a solid or various forms of solids are burned during combustion for generation of energy, that fuel is solid fuel. This form of fuel is not widely used because of difficulty in handling, storing, and disposing of the residue. Coal was popularly used as fuel. Some other examples of solid fuels are wood, charcoal, wood pellets, peat, etc. Liquid fuel. In today's scenario, it is the most commonly used fuel in almost every internal combustion engine. Liquid fuels are easier to handle and to use. Examples of liquid fuel include gasoline, diesel, kerosene, jet fuels, methanol, ethanol, propane, butane, etc. Derivatives of liquid petroleum, alcohol, and benzyl are also used. Gaseous fuel. These are the most ideal form of fuel because of the tendency to mix homogeneously with air and avoid the problems caused by other forms of fuel, even though they are not widely used due to trouble in storing and transporting. This fuel category can be divided into 4 classes: natural gas, producer gas, water gas, and coal gas. Commonly, they are used in power plants. Hydrocarbons constitute a large part in petroleum and natural gas. Hydrocarbons is made up of 2 words, hydrogen and carbon. So, as per the name suggests, hydrocarbon is a class of organic compounds composed of the 2 elements, that is carbon and hydrogen. The carbon atoms join together to form the structure of the compound, and the hydrogen atoms are placed in different configurations. These are the principal constituents of natural gas and petroleum, which serves as a major fuel for internal combustion engine. Basic families of hydrocarbons are paraffins. Paraffins are alkanes which have a chain-like molecular structure. Paraffins are saturated carbons, that means that they are bonded with only single bond and the compound has maximum number of hydrogen possible. The structure is stable. Olefins. Olefins are alkenes which also have chain-like molecular structure. Olefins are unsaturated hydrocarbons, that means that they have at least one double or triple bond. The structure is unstable. Naphthenes. Naphthenes are cycloalkanes or cycloparaffins. Their molecular structure is like a ring. Naphthenes are saturated in nature and they are also stable. Aromatics. Aromatics are derivatives of benzene. Their molecular structure is also like a ring. They are highly unsaturated in nature and their structure is most stable. Petroleum, which is largely used as fuel for IC engines, is mined from under the surface of Earth in its crude form. It needs to be refined to be suitable for use in engine. Petroleum refining process. Oil or petroleum refinery is an industrial plant which utilizes various processes and techniques where crude oil is transformed and refined into useful products like petroleum, gasoline, diesel, etc. It is based on the principle that as we increase the molecular weight of hydrocarbons, its boiling point also increases. Crude oil refining is divided into 3 stages: separation unit, conversion unit, and fishing unit. Various refining processes include cracking. It is a process of breaking down large and complex molecules into small and simple compounds. These smaller compounds have lower boiling point. Cracking is of 2 types. Thermal cracking. This type of cracking subjects the heavy hydrocarbons to high temperature and pressure. These are further decomposed into smaller molecules. Catalytic cracking. This type of cracking makes use of some catalysts because catalysts provide better anti-knocking properties. This is done at lower temperature and pressure. Hydrogenation. This process converts unstable compounds into stable ones. This process includes the addition of hydrogen atoms to hydrocarbons under the condition of high temperature and pressure. Polymerization. This process involves polymerization of olefins into heavier stable compounds. Alkylation. It is a process of combination of olefins and isoparaffins to produce high-octane gasolines or branched-chain isoparaffins. In this process, presence of some catalyst is required. Isomerization. This process changes the position of atoms within its molecules without changing the molecular formula. Normal structure changes into its isomeric structure alkyl, which increases the knock characteristics. Reforming. It increases the anti-knock quality of the fuel. It converts the low anti-knock quality into high octane rating. You will learn about these terms later into this video. Blending. In blending, different products are mixed in different proportions to obtain desired effects. Cyclization. This process joins the end of a straight chain molecule to form a ring or cyclic compound of naphthene family. Aromatization. Aromatization is similar to cyclization, with the difference that the final product to be obtained is of the aromatic family. To define a fuel as good fuel, it must have certain set of characteristics. The analysis of various qualities that a fuel should possess are slightly different for SI and CI engines. For CI engine fuel, the characteristics are volatility. It is an ability of fuel to convert into vapor form. Volatility of fuel should be sufficiently high for proper mixing and burning. If the volatility is low, less fuel will boil off from the injector and hence less hydrocarbon emissions will occur. Ignition delay. If the ignition delay is too long, it results in high knocking, and if it is too short, then smoke will form due to insufficient mixing. Anti-knock characteristics. The anti-knock characteristics of a fuel should be good. Heat of combustion of the fuel should be high. Specific gravity of the fuel should also be high. Viscosity. Viscosity should be low as to ensure easy pumping, but high enough to provide some lubrication. Cloud point. Cloud point is the temperature below which the wax content separates out as solid. This solid can clog fuel pipes and cause hindrance in flow in pipes. So this should be low. Pour point. It is the temperature below which the fuel freezes and makes the flow difficult. This should be low as well. And now for SI engine fuels, the characteristics are volatility. Volatility affects how easily you can start your car, warm it up, and how well it runs. A fuel can have front-end volatility in which 0 to 20% of the fuel is burning. It makes it easier to cold start the engine but more difficult to hot start it. That is, the engine will start easily when the engine temperature is colder than the normal temperature, but at higher temperature it will be difficult to start the engine. It can also cause vapor lock, which is an interruption in the flow of liquid through a fuel line or other pipe as a result of vaporization in the liquid. Evaporative loss is high in front-end volatility. Mid-range volatility. 20 to 80% of the fuel is burning in this category. This increases the warm-up performance of the simple ignition engine. It increases short trip and decreases long trip economy. Acceleration, power, and smoothness increases, but the chances of carburetor icing increases as well. Tail end volatility. In this, 80 to 100% of the fuel is burning. This often results in crankcase dilution, that is, some of the fuel accumulates in the crankcase. It also increases the chances of spark plug fouling as the fuel coats the nose of the spark plug and blocks it. Anti-knock quality. This quality depends on chemical composition and molecular structure. The anti-knock property of the fuel depends on self-ignition characteristics of its mixture. High compression ratios can be employed with high anti-knocking quality. So, SI engine having high anti-knock property is considered to be the best. Gum content. Reactive hydrocarbons and impurities have a property to oxidize upon storage, which give rise to the formation of sticky and gummy substances. That results in sticking valves, pistons, clogging of carburetor, carbon deposits, etc. This property is least desirable. Sulfur content. Sulfur content includes free sulfur, hydrogen sulfide, and other sulfur compounds. This increases the corrosive nature of the fuel, which is dangerous. This property is not desired in fuel. Rating of engines. SI engine's fuel rating is based on its anti-knocking property. The knock quality is rated by comparing with primary reference fuels or PRF. It is rated through octane number rating. Octane number is the percentage by volume of isooctane in a mixture of isooctane and N-heptane, which exactly matches the knocking intensity of a fuel in a standard engine under standard operating conditions. The first is isooctane or 2,2,4-trimethylpentane with octane number rating 100. And the second is N-heptane with octane number rating 0. In CI engine 2, the knocking quality is rated by comparing with primary reference fuels. Here the fuel is rated by cetane number. Cetane number is the percentage by volume of N-cetane in a mixture of N-cetane and alpha-methyl naphthalene, which has the same ignition characteristics as the fuel in a standard engine under specified operating conditions. The first one is N-cetane with cetane number 100 and the second is alpha-methyl naphthalene with cetane number 0. That is all for this video. I hope you like it. Thank you for watching.